When I'm at any kind of show like Formnext, I usually spend the first day or so just scouting what I'm interested in, what would make for a good story. And I realized we had basically the whole chain of filament making right there, from cradle to grave, from even before the filament is being made, filament producers, and then what happens to the stuff you want to recycle. So as part of that, I also interviewed recreators who are convinced that everyone should be switching to their 2.2mm filament. I talked to ColorFab to understand why it is that PLA and other filaments don't decompose as well as you'd think, and to Recycling Fabric on why it makes sense to ship your used prints to them and have it turned back into fresh filament. But it all starts with that fresh filament, and that's typically not just the raw polymer pellets. Chances are, if you've printed with European-made filament, you've already used a material that was made with a master batch from Grafe. And from talking to filament manufacturers, I get the impression that these guys are genuinely interested in helping them make awesome filaments.
We as Grafe, we are a master batch producer. We make the colors for master batches. That means filament producers come to us and say, okay, we want this nice green with some flitter inside, and we want to do it in a PLA or PETG, whatever. And then we as Grafe search for the different pigments. We mix the green pigment with a gold flitter, also a bit black, so we have to mix it like in an art lesson, that we mix different kinds of pigments together to achieve the color our customers, the filament producers, want. We melt the pure polymer, virgin polymer, without in color or in real color, and if we have melted the polymer, we can bring these pigments inside to the polymer. That looks then afterwards like that. We have here a granulate, and this is named as a master batch. We put much more of this powder into this master batch than you normally need. That means we create a concentration of pigments together. Our customers can mix it with the pure polymer, like a dosage of 2 or 3%, to get their plastic parts out of it. And it could be a filament. You use only 3% of our master batch in a pure polymer, and then the filament producers melt this combination, extrude them, and we'll get this color. Normally, every one of you could go to their filament producer and say, hey, I want my own color, and then we will set a master batch, a color combination specially for you. And this didn't end with the color. We can also introduce some other things into a filament, like a UV stabilization, a flame retardant, what else? Or maybe also some very, very special things. In this case, yes, it's a shoe, and I would smell on it, because we bring a smell directly to the filament. We can bring anything into plastic, what you want. We have the tailor-made version for your own application, like you wish for it.
A product you will very likely also have used is, a spool. Who is this one from? Yeah, this is a different one. You might not give it a second thought, but not only is it a core part of what makes filament usable, it's also a rather large amount of plastic you've consumed alongside the filament itself. I always find it so interesting talking to companies that otherwise you wouldn't even give a second thought to, because they too have their own unique challenges. I probably have dozens of rolls of filament, some of them probably behind me, that are wound on Alpa plastic spools. Mostly, their constraints right now are based around compatibility with the setups that end users actually want their filament to work with. And that basically means Bamboo Lab compatibility, both with the AMS and the filament refills. So, Alpa Plastic are not only making classic solid spools, but have also started producing two-part spools with a bayonet mount and a cardboard core. Thankfully, refill spools are pretty standardized around the open master spool standard, so shipping filaments on these spools provides real added value to users. You can use bamboo, dust filament, or any other compatible filament refills. Oh, and these two-part spools are also really compact to ship. Full cardboard spools had their moment for a while, but they're hard to make refillable, so we're moving back to all plastic spools, it seems. Alpa Plastic are offering most of the spools made from a, mostly recycled plastic too, and how I understand it, this is an input material that is already a low-grade plastic with contamination from a mix of polymers, so it's harder to process, and the properties of the resulting parts will be a bit more all over the place. But it's still more than good enough for making spools. Those don't need to be super high performance, and I think that's a much better use for these recycled materials than just burning them for energy, which you can still do with the second life spool. It's pretty cool to see. And what was also really cool to see was today's sponsor, Anycubic.
This part of the video is sponsored by Anycubic, and they've got two cool new products to show you. The first one is the Anycubic Cobra X.
Cobra X is our new entry-level open frame 3D printer for new users, and it can handle 4 filaments at the same time, and it can print like hard and soft materials at the same time as well.
This is going to be a pair of pliers that is going to be flexible and mechanically usable, and it is TPU with PLA.
Right.
And that's possible because the Cobra X is not relying on an external filament feeder box to handle the switchover. All the filaments stay loaded up to the head all the time.
So all the magic is in the print head. So we have shortened the filament changing path like substantially, and also we have optimized the waste of the filament purging.
That's all the waste here?
Yeah.
They're calling this setup the ACE Gen 2, and the Cobra X will be available on Kickstarter this January.
And in the background, we've been hiding the Cobra S1 Max.
And the S1 Max packs a well-rounded set of features. Its print volume is 350mm cubed, which is about the maximum reasonable size before it starts compromising other factors. Of course, it's fully enclosed and has an actively heated chamber up to 65 degrees, so warping with large prints won't be an issue. Combined with the 350-degree hot end, that even makes it capable of printing high-end engineering materials. Anycubic is focusing on software support and reliability, and you can check out the pre-order for the S1 Max at the link below. One row over from Alpa Plastics was Recreus, and they ended up being quite the talk at Formnext because they apparently think introducing a new filament diameter standard that doesn't work with any printer on the market right now would be the reasonable thing to do. But why though?
Why?
This is the question of the show. We can print to 3 times to 5 times faster with very soft materials. For example, we are printing here with a 82 Filaflex and 18 millimeters cubic per second with a 0.4 nozzle. We have been testing the different kind of filaments because we want that to move flexible filaments to the next level, okay? To print faster as a regular PLA. And we have found that the 220 has the right balance between a 58% of more cross-section, but it's not big enough as 285 to be melted fast. And we find, and you say, okay, why don't you use 285 to print flexible? Yes, because it's not thermal efficient as the 220. And the good thing is that the very tricky material like a soft 78 or 68 that are really tricky to print, you can increase up to 8 millimeters per second printing with this material. And it gives you more reliable prints, large prints, and more speed. The only thing that you need to change is the hot end. We have create new hot end that are available in our website. And this hot end has a bigger inner channel that allows you to introduce 2.2 and also totally compatible with 1.75 regular PLA filament. I have made more than the 1,000 hours of tests printing TPU in 220 diameter, then switch to another 24 hours of PLA in 1.75, switch into different kind of polymers in 1.75 and 220 with no problems, no clogs, and working like a champ. The retractions, you don't need to change nothing in your current parameters of your filament. At the moment, it will be available in the first batch for the Prusa ecosystem, next extruder ecosystem, and also for the P1, X1 series of the Bamboo branch. And the H2D series, it will be available in the next month. The best benefit here we can achieve with the soft materials, because the soft materials, due to the slightly more cross-section, we can push faster and it becomes really reliable to print.
That's a bold strategy. We'll see if it pays off. One filament that Azurefilm was really keen on showing off was, in the standard 1.75 millimeters, was PEBA, P-E-B-A. They were pretty busy already when I stopped by, but it's a really bouncy filament. Most of the flexibles have a pretty strong damping behavior, but PEBA is a lot more springy and probably has some really neat engineering applications. RC car springs, maybe? So that's the production part of filaments, but what do you do when you've printed something and you figure out you don't need that part anymore, or you manage to create enough poop during a print to fill up 2 new spools? Well, Recycling Fabrik are one of the few companies that figured out how to accept old prints from users, do it in a way that is ecologically responsible and sustainable from a business perspective as well. Now, I've always been very suspicious of thinking about it, well, actually anything that makes big promises, really, but especially about 3D print recycling. I have 3 pet peeves with the claims that are often made here. First, when I and probably most other people hear recycling, they think about the trash and plastic they throw away and that being sorted and turned into a new product. But what's usually happening when a company claims recycling is that they're using production waste and not so-called post-consumer materials. Think injection molding. You've got the part itself, but every mold also has sprues and runners, there's purging material, failed parts, and so on. And all of that is basically virgin plastic. There's no contamination from other polymers, so it's perfectly good raw material, and that would get so-called recycled anyway, right? Well, apparently, while reusing that waste material is super easy when you're making cookies and just roll the material, your dough into a fresh sheet, when it comes to reusing the production waste plastic, that process of collecting and shredding that waste, ensuring it has consistent quality, all of that, costs basically as much as producing fresh pellets. So companies working with plastics actually pay to get rid of their waste, even though it might look like perfectly usable material. Recycling Fabrik are pretty transparent about what materials they use. It's about a 50-50 mix of post-consumer and industrial waste. Second, how can you possibly create quality filaments from random print scraps from users? They only accept PLA and PETG scraps for now, and they expect users to keep those sorted. However, there are studies that show that up to 10% contamination with the wrong plastic doesn't really change the properties of the plastic itself, and Recycling Fabrik managed to get much lower than that. But also, they do blend their input materials to get a consistent output and add fresh additives to balance out especially colors. There's also a matte and super matte black version as well. Those cover up basically any color, including sparkly inputs. They then put everything through a compounder and a filter that removes solids larger than 120 micron, and then it gets processed into filament that they say is just as good as any other. The extra cost of this process is calculated into the store credit system they use for people sending in their old prints. And lastly, this surely can't be more ecological than using fresh PLA, right? After all, that's a bioplastic. But no, they actually had a case study done, and even accounting for people shipping in their old prints, through the mail, recycling the plastic is still better than using virgin materials. They also accept your old spools and will wind fresh filament onto them, or directly ship you a refill core without the spool at all. Recycling Fabrik are in this because it's the right thing to do, and they've got the research to back that up. They've also figured out a way to, make it viable as a business, so yeah, I'm rooting for them. Go check them out. Though no circular process is really 100% watertight. Ideally, non-recyclable trash at least gets burnt, but there's always some material that makes it out. Interestingly, as a filament maker, ColorFab totally acknowledged this, but they're also actively working on being a part of the solution as well.
Thank you, Thomas. We have been working hard on all PHA. PHA is the only true natural plastics replacement made by nature. Most plastics that we know, including PVOH, including PLA, are synthetic materials that are under certain circumstances biodegradable. PHA is produced using fermentation, so take natural resources, sugar, natural oil or starch. Bacteria can digest it and produce a polyester that we can extract and use as a plastic replacement. It's nature's plastic, so to speak. The main difference between natural plastics and synthetic plastics, very good question. So every plastic will degrade. It breaks down into small pieces, which we know as microplastics. Microplastics in nature, from synthetic resources, they don't biodegrade. They remain small plastic particles that enter your waste, your water streams, that enter your food streams. It keeps in the loop. With PHA, For example, if I bury this vase in the soil, microorganisms completely digest the material. It's food. They can completely metabolize it, opposed to synthetic microplastics.
I'm going to interject here real quick because what made this whole thing click for me is this, and it's not that clear from the interview. The core reason why PHA can be consumed by nature is because PHA is also produced by nature. Whenever nature has a process that creates one type of material, micro and macro organisms adapt to it and figure out a way to make use of that material. PHA has been naturally occurring for millions of years, so anywhere you look you'll find bacteria, fungi, algae and archaea that can consume PHA. Most other plastics, including PLA, don't naturally occur, so there's nothing there that would know how to efficiently consume them, so they stick around.
If I touch this pot, it will not start to degrade in my hands. Bacteria need to install, multiply, release enzymes. This takes time. So bacteria can feast, they can digest PHA. The process, of course, on the high temperatures goes very fast, but it requires the presence of microorganisms. PHA is a semi-crystalline material. It crystallizes slow. So to reach a certain processing window, you have to modify it, make recipes of different PHAs. It's not an easy task. We've been doing that now since 4 years to reach a grade that mimics plastics, that has processability, functionality at an affordable price. That's the job Colorfab's doing. Some novelties, we have been working to increase the processing window to make it more easy to work on different platforms. Material is certified food contact compliant, EU, FDA. Also, before the end of this year, we expect TÜV Austria soil biodegradable certification. So recycling is one way to get your materials back in the loop. The big question is, how many times can you recycle a product? Plastic is not recyclable for 50 or 100 times. In the end, it will be lost in nature, it might be burned or be discarded. So a plastic recycling rate typically is very low. Let's say 5% or 10%. I don't have the exact figures. But we use 500 million tons of plastics a year. Not all of that is recycled. So our linear consumption is still a big threat for the generation of microplastics. Let's call it overconsumption. So with PHA, we don't have this problem, but it's still a niche. It's a small segment, of course. Recycling makes a lot of sense, but it's not the finite solution. So this micro booth here is for a project we've been running, Print the Planet Green. What we're trying to do there is to introduce a waste stream that we all know, eggshells. Eggshells contain calcium carbonate, which is a natural resource used by the chickens. We can extract up to 30 tons a month to use as a filler to increase the properties of PHA and reduce the price of PHA. And doesn't look bad at all, right?
All right, I think that's a positive note to end this one on. Formnext also had a ton of large robot 6-axis printing going on, and I felt like this year was a bit of a turning point towards multi-axis printing becoming a viable tool. But that's the next video. Take care of yourselves, keep on making, and I'll see you in the next one.